The unicycle gives us a chance to explore the different forces and torques acting on an object that is rolling down a hill. This subject matter is fairly advanced, usually taught after an introductory high school physics class. The main idea here is that the wheel can slip with respect to the ground, peeling out if you will, or it can roll without slipping. We will investigate both of these cases. Let's start by just hitting play and seeing what happens. As you can see, the unicycle and rider start accelerating down the hill. This is not because the cyclist is pushing on the pedals, it is just the rolling motion causing the pedaling. The rider is just keeping up. As we can see in the graph at top, the speed of the cyclist, shown in red, increases with time. Likewise, the speed of the edge of the wheel, as seen by the center of the wheel, is increasing. That is, the wheel itself is spinning faster and faster. As long as these two speeds match one another, as we see they do here, the wheel will always keep up with the road, and there will be no slipping between them. Let's look at the forces acting on the cycle by showing the free body diagram. There are three forces acting. The first is a downward force acting on the system due to gravitational attraction to the Earth. The second is a force pointing upward and rightward, the normal or contact force acting on the wheel from the road. The third, a friction force, points upward and leftward. This is either a static friction force if the wheel is rolling without slipping, or it is kinetic friction force if the wheel is sliding. Since the wheel is not slipping, this force is static, yet it works to both slow the wheel and also spin it faster. In fact, this friction force generates a torque on the wheel, causing the wheel to accelerate in a rotational sense. The other two forces do not generate torques about the center of the wheel. That is because they both point through the center of the wheel, and so they generate no perpendicular component of force, and therefore no torque. The gravitational force can generate a torque if the rider leads forward or backward. However, we're going to neglect that possibility here. It is hard enough to balance as it is. Under what conditions might the rider slip? Let's try this. Let's lower the friction coefficient to 0.3, so it's easier to slip. Let's lower the mass of the rider to 30 kilograms, a child. And let's increase the ramp angle to 60 degrees. Now let's hit play and see what happens. As you can see, the unicycle speed increases with time just as before. In fact, quite quickly since the ramp is so steep. However, the speed at the edge of the wheel, as seen by the center of the wheel, increases too slowly. The friction is too low to spin it up. This means that the wheel slips with respect to the ground, a dangerous situation for the rider. Understanding how rolling with and without slipping is analyzed is an important part of an advanced physics course. If you are interested to see more, please check out our bowling alley simulation as well. Thank you for watching.